Welcome to tonight's presentation in UCI's Sustainability Seminar Series. It's a great pleasure to introduce to you Dr. Linda Fernandez. She is an Associate Professor of Environmental and Resource Economics at the University of California, Riverside. Her work explores economic incentives for pollution control and natural resource management at different levels of social organization. She began her career as a student at UC Davis, where she did her bachelor's degree in international agricultural development. She went on to the University of Hawaii, and while a master's student there, she worked at the East-West Center's Pacific Islands Development Program, looking at development and water protection projects for small island states. She then spent several years working with the EPA, the Environmental Protection Agency, Region 9, on water quality and agricultural projects involving economic incentives to reduce pesticide and erosion emissions in waterways. She did her PhD at the University of California, Berkeley in agricultural and resource economics. Tonight she was going to talk about pollution control across international borders. Please join me in welcoming Dr. Fernandez.
I'm happy to be here and participate in this seminar series. And today is actually a perfect day. I'm glad it started raining today because it's a constant reminder of precisely one of the mediums we're going to study. We're actually going to be talking a lot about water, its flow, and what it might carry with it between countries that share borders. In addition, I'm actually going to be alluding to some air issues too. And so keep that in mind, just, as you walked around today. Granted, the rain was light, but as it rains on us, it's irrespective of any sort of barriers between us, or for that matter on a larger scale, between countries. And so what I'll be highlighting with a few pointed examples today of my own work, research that's actually been used at different scales to inform policymakers and sort of have them refine some of their efforts on decision making, is really examining when there are these shared pollution problems. In many cases, the recognition of some very fundamental differences, both physical and economic differences between countries, should be part of the discussion in pondering solutions. It can influence incentives, how you go about structuring management strategies. And so I'll highlight these with a series of illustrations, discuss some particular transboundary pollution problems in our own backyard and on our own continent, so binational, trinational sort of transboundary pollution problems. And because I'm an environmental economist, I'm going to convince you, hopefully, that some economic analyses I've done that combine natural sciences, social sciences concepts really are quite useful to elucidate some policy and institutional solutions that have taken place. And because these are in fact quantitative, it's involved some effort on my part to actually go collect some data, do some field work. So I'll march through on different scales what that's actually meant, and you'll get a feel for sort of the variety of effort that has to go on in these economic analyses to do it right. I'll be highlighting some results that have actually helped to ponder over the long term some very serious investments in solving these problems at the binational, trinational levels. And then draw some very fundamental conclusions that we can take away and see this as a perspective of very good examples for the rest of the world in what might, in fact, be long-term sustainable solutions for these problems. So through a series of some maps, I'm going to talk through maybe what a lot of you already probably know from perhaps travels in some of these areas, but I'll just kind of elucidate some really basic concepts that are important to recognize. So this is, in fact, our continent, North America, and I'm going to highlight a couple of key areas that we're going to be looking at. Here's a long border. This is the US-Canada border, and from this map, its orientation, you might think naturally that that north to south sort of orientation of Canada up at the top there, the US in the middle, and then here's another international border, the US-Mexico border. That north to south in general implies the general direction of a lot of pollution problems. And I'll just say I'm going to raise a counterexample and show you some proof of where it's important to kind of recognize that these are very long borders. There's often very different sorts of gravitational flows going on, both in terms of water flow, air shed flows, that matter in terms of all the countries caring about the pollution problems they share, and or what they can do about it, in terms of if they're actually endowed with the resources or not, whether they're upstream or downstream to do anything about these. So let me just point out what these borders look like, and then we're going to take some closer up views. So I don't know if anybody's ever crossed this border at any point along the way here, but let's just notice a couple things. Here, you've probably heard of these big giant pools of water that in fact they are the largest conglomeration of fresh water in the world. They constitute about 25% of all fresh water in the world, the Great Lakes system. And we can imagine they're shared bathtubs between the two countries. Keep that in mind. It's a different sort of perception of shared waterways than a river that might actually flow north-south, or, as we're going to actually look at, a river that flows south-north, going out of Mexico into the US. Whether you're upstream or downstream should matter. Whether the water quantity or quality that one starts with upstream and how it might actually gather momentum, gather pollution along the way, and where it ends up downstream can matter in terms of how you're affected by this water flow, and then what you might care about trying to change those impacts to you. So what we're actually going to be spending time with first, because kind of sort of build up the scales of analysis here, I'm going to focus our discussion first off in one watershed, and then build up to an entire borders perspective of how some decisions have been made across many watersheds. And then we're actually going to look at the trinational picture of several airsheds. So keep this in mind that even though, again, the north-south sort of orientation of things doesn't always imply that the wind blows north-south to deposit everything into the US, let's say from Canada, or the US into Mexico. It could be that things flow south-north to change the perception of who's downstream or down airshed of things. Okay, let's look at the southern border and the way in which this drawing is depicted. It's not quite to scale. By the way, this border is about 1,800 miles long. And just to give you an example of how water can flow differently, here's the Colorado River, where it originates in the state of Utah, ends up flowing into the Sea of Cortez here in Mexico. It is, in fact, a north-south orientation of gravitational flow. And a lot of people depend on it for water supply, and/or it picks up some pollutants along the way. People care about cleaning it up along the way. So there's been some expenditures there. Another river that's of interest is the Rio Grande, which is, in fact, the river itself is the international border. And it actually is a significant part of the border from the edge of New Mexico, state of Chihuahua, down into the Gulf of Mexico here. Okay, so water flows kind of vary along this border. What we're actually going to be, and in some cases, just point out this really interesting river here. this is in the southeast part of the state of Arizona into the state of Sonora, Mexico. It actually leaves the U.S., goes down into Mexico, comes back into the U.S. There's been some really interesting management arrangements there in terms of expenditures of first being upstream, then being downstream, in terms of caring about where the water ends up and the quality of it along the way. Okay, another map I wanted to show you, because this gets into the nature of some focal points of these borders of North America and how we are in some ways very parallel to the rest of the world. At one point in history, it was often considered that borders were sort of buffers, barriers, to kind of have some sort of protection against your neighboring country. Whereas, in a very real way, this map, and I don't expect you to actually be reading all the type on this map, I'll just say this, sorry, it's a sort of a cut and paste job out of a report, and it's basically attempting to illustrate major cities that face each other along the border, this international border, and in fact, they literally are straddling populations where people are very connected, facing each other in two different countries. I'll give an example. The corner of the state of Texas and Chihuahua, Mexico, El Paso, Texas, Ciudad Juarez, they literally only have to walk about 100 feet over a bridge, and the two cities are very connected. In fact, their economies are very connected. And so, in some cases, this border is rather seamless in terms of people dealing with each other every day. In a very real way. And they, in fact, care very much about the air they share and the water they share between them. And it's become a focal point of discussion to motivate a lot of that the problems were becoming quite apparent to residents of this border area, that something over time needed to be addressed of their sort of constant battles with water quality, air quality. So keep that in mind. There's about 14 cities that face each other on this is again about an 1,800-mile border. It's about half the size of the US-Canada border. And let's go over some variation in what's happening along the southern border, because one of the watersheds we're going to look at is actually on the southern border. So basically, in a very real way, these cities have been growing over the past, let's say, 30 years. They are big, heavy concentrations of population in terms of a lot of movement, let's say, from interior Mexico to locate at the border for a lot of labor opportunities. I'm not sure if you've heard the term for a lot of assembly plants located just on the other side of the U.S. in Mexico on this long border. They're called maquiladoras. How many of you have heard of that word? Okay. These are assembly plants which basically consist of a labor force down in Mexico assembling, oftentimes it's electronics, various sorts of industries have located down there, and through some agreements, the products are then sent back to the U.S. or into Canada under some agreed upon arrangements to have labor force down there. What that's meant in terms of these cities are that a lot of people want to go there and work, find opportunities that don't exist elsewhere, let's say in Mexico, or for that matter, not quite available in the rest of, let's say, the state of Texas, but are closer to the border. So let's just think about this. Okay, there's a lot of people living in this area. The wage rates may be higher than the interior. The cities themselves, we could actually go back. Well, I'll just note that if we look back on this map, and I just pointed in general south of the border to say that it's quite a serious, significant distance down to the heart of Mexico, the capital of Mexico, Mexico City, and then it's also quite a significant distance over to our capital, Washington, D.C. And in many cases, the orientation of a lot of governance is quite different between the two countries. A lot of financial decisions for management on a very basic level in Mexico are very centralized at Mexico City. So in fact, cities along this border do not have their own separate structure of budgeting, and actually, I don't know if a lot of people participate in the election type process here on a general basis, but oftentimes on our ballots, there are often some efforts, perhaps some ponderings to vote through bonds to help pay for things at very different scales of governance, let's say county level bonds or state level bonds to do things. Well, in Mexico, that's not really the case, that they have this ability to raise funds for a lot of public works projects at the city level. So I raise this issue as a means of saying these border cities are quite different in terms of their ability to finance anything that might be going on in the city. And that's, it's just something to note that perhaps the Mexican counterpart, let's say Ciudad Juarez, facing El Paso, might not have the same municipal budgeting abilities to do things, let's say to address some water quality issues. Keep that in mind. And here's something important to note that's going to come up later as we talk through some financing channels, that production at the border, remembering in these assembly plants, it may be the case that the labor forces down in these areas are really producing things, and they might be, utilizing some inputs there at the border, but a lot of these products that go elsewhere. So consumption's happening elsewhere for what's being produced right at the border. Now, back in the late 90s, there was this, I don't know if you've ever seen this acronym before, this is an acronym for the U.S. General Accountability Office. It's kind of this investigative arm of the U.S. Congress. And their role is really to do sort of this investigation of where public funds might best be directed. That's their role. Back in the late 90s, they did this comprehensive analysis. They often gather a lot of information from some experts to make some projections on what was necessary on this southern border, the U.S.-Mexico border. Here's what they found. And by the way, this is late 90s dollars, so just keep that in mind. That they were projecting that about 180 projects, I'll just say the label there, projects mean, in order to do various forms of pollution control, let's say the water pollution issues I was alluding to, some air pollution issues that I'll spend some more time describing in a bit. They were identifying that about 180 projects in total would really help this region out. The 800 miles, 1,800 miles worth of this border with those 14 cities grouped around each other. And about that much, and they were guessing that the way in which these different airsheds, watersheds are connected, that about, of the 180, 120 do need to be in Mexico and 58 in the US. General sort of projection at that time. And keep that in mind, that number 180, because we're actually going to walk through some analyses where we're getting now pretty close to meeting that total amount. But I'll tell you something more about that along the way. Okay, let's even take a closer view now of one watershed that we're going to actually see a lot of my efforts to analyze what's happening, and then we're going to move out and scale. What are we looking at here? Well, it's the Tijuana River watershed, and it's a south to north flowing. I'm just pointing at the upstream. This is Tijuana, sprawling Tijuana, and I don't know if you can really see this. The resolution of this map is kind of varied, so I'll just point out that this is actually a very steep, kind of with some definite ravines and gulch type settings here, where there's quite a bit of urban development, often unplanned, throughout Tijuana that straddles a lot of different steep gulch erodible type areas. There's a particularly important canyon called Goat Canyon that's actually been the basis of a lot of measurement of some aspects of connectedness in this watershed. So here we are. This is the upstream part of the Tijuana River. So let's just imagine that the entire drainage, let's say, starts up in the upstream part of the watershed. It then is carried over the border, in some cases quite diffusely, out of these canyons into, by the way, this red line is in fact the US-Mexico border, into the southernmost part of the continental US. And this is actually designated as the label here. It's a national estuary of significance in our country, according to the US Fish and Wildlife Service, in that it's a quite large wetlands that supports a lot of habitat, migratory habitat for birds, things like that. And this is the southernmost beach in the continental US, Imperial Beach. Not sure if anybody's ever heard of that beach. But this is the ultimate drainage passageway of what flows out of Mexico into the US. Now I'm going to bring up this aspect again of the erodible, steep nature of this, urbanization happening in Mexico. Oftentimes, again, it's been in the mode of this labor moving into the border area for job opportunities, things like that, without a lot of attention, let's say, that Irvine, California placed on doing, planned urban growth. Hasn't happened in Tijuana on the scale of Irvine, as you're probably really familiar with living here. It's quite manicured and managed type urban development. Not the case in Tijuana. Let's just summarize a few aspects of this watershed in words that are going to become important for investigating the economic analysis, some ways in which water pollution, going back to this picture again, I'm going to say that when it rains in these areas, some noticeable types of things that flow with the rainfall are often people's property. This unplanned, kind of sprawled, perhaps they're quite basic structures for people to live haphazardly in some cases, may in fact just erode down the hillside and be quite, dramatic in terms of property loss. And so oftentimes what is a very real aspect of this sort of, you'd call it stormwater runoff, because it's not often channeled in a proper pipe type way, might actually be a combination of erodible material, so sedimentation, the actual aspects of what might be some solid waste, along with some sanitation issues. Some unsewered wastewater flow comes over the border here too. Okay, so let's get a picture of something of defining this watershed in terms of hydrology, physical type setting here. So this is a huge watershed, and 3/4 of it is considered Mexico's, residing in Mexico upstream. Downstream, as you saw in that picture, is this wetlands of national significance. And I'm not sure if anybody's heard of this convention. They're celebrating their 40th year this year, the Ramsar Convention, that designates wetlands of international significance. Apparently because this particular setting is quite a flyway for migratory waterfowl, traveling the Pacific Flyway. And we have this recognized source of a lot of the concern of this binational water flow, that this sprawled activity means there's a lot of things coming over the border that may mean, this runoff is laden with a lot of things that probably shouldn't be coming across the border. The erodible sediment, the stormwater, the sanitation, untreated sewage. Okay, and now to get into some aspects of how hydrologists see things, we have to imagine that from upstream, there's this way in which you model water flow, that it's it flows at a rate. Let's say it's, gallons per minute, something a measure like that, and then it accumulates somewhere. And somewhere in the water flow, there may actually be pollutants that we might care about in terms of where they settle. And so part of what my job is as an economist is often to talk to these other people, natural scientists, other social scientists, to do a very good job of characterizing things like pollution flows, financial flows, management flows. And so I raise these issues because I have to do something about capturing these in my analyses. And I'll show you how I attempt to do that. First off, I'll raise this asymmetry or this difference, again, going on between the countries because it really does matter to motivate incentives or caring on the part of both countries sharing this watershed. So again, I'm an economist. I care about financing issues and costs and benefits, again, in this case of pollution problems in this shared watershed. And so the ability to finance this cleanup between the upstream country and the downstream country isn't the same, bottom line. And again, even the source of their funds isn't the same. Again, things happening in Mexico City, it may not be that Tijuana has their own source of bonds to have people vote, to set aside money, to do things, let's say, like sewer management or proper urban management, things like that. So that's just sort of something to be recognized, no formal bond structure. The US, more decentralized. The city of San Diego, look at their budget, is quite a bit larger in terms of Tijuana's overall budget that's handed to them for Mexico City. And in a very basic way, the people who live in these cities, let's call them the users of some of the public utilities, if in fact they'd be provided, vary in their abilities to pay. And this is just a basic variation going on in, let's say, the minimum wage structure of both cities facing each other. Okay, and so, in fact, when I, as an economist, am attempting to try and model or investigate what's happening in this watershed in the past, currently, and on into the future, I draw on a series of tools that in many cases means that my job is really to match the scale of management with the scale of the pollution problem. Remember, this is a binational pollution problem. It's going to involve binational decision makers. So there's this phrase for the way in which the framework would be a good thing to model more than one decision maker, and that's game theory. Not sure if many people have heard of that, but it basically means you're involving a really good definition of all the stakeholders involved. If there's more than one stakeholder, a game involves at least two people, maybe even more than two people or two countries, to try and ponder what are the sort of different options one might have if two people, two countries do things together versus trying to do things separately. In a gist, that's what game theory and some efforts to model things using game theory involves. Really basic questions: where to solve the pollution problem? Do you do it upstream? Do you do it downstream? Do you do it in both places, both countries, in this game sort of setting? And if we recognize already that there's some clear differences between these countries, one country sending pollution to the other, one country more endowed financially, how much is in each country involved really? Can we call it equitable just to say let's divide it in half? So really my efforts are really to, in a quantitative way, explore what it really means for countries to cooperate. And I'll actually give you a slew of different options for what cooperation could actually mean here. It's not just one one option. So, but in a phrase, it would actually mean that they're doing things together versus comparing non-cooperation where they might act alone. Supposing it's the case that in the end the downstream country is strapped with everything, what would that mean in terms of, an outcome? Would it be completely impossible? And what I'm going to be tasked with then is to do a really good effort, because this is in fact an empirical study, to look at the case where there's entirely different, in a quantitative way, pollution control costs upstream and down. The flow and stock effects for upstream and downstream differ, the ability to pay, and then some measurement of damages. And I'll allude to some efforts that actually involve some UC Irvine people on damages that I worked with. But the ultimate, the answers that I want to provide help with, sort of responding to these questions. What are the gains to cooperation from specifically wastewater control across this watershed? And what can induce cooperation when you have such variety, such difference going on between, in this case, the upstream country experiencing different types of costs and damages than the downstream? Okay, I'm going to talk through now some definitions that come not from me, but the international setting of governance, where some other people have tried to ponder varied topics of getting countries to work together. Maybe some of you have heard of these concepts, maybe these are completely new. I'm going to try and just kind of make these definitions simple. You can read up on these later on, because they are quite fascinating and have been used in different settings. The Helsinki Rule actually comes from a bunch of lawyers who've pondered some cooperation issues on varied topics, from defense to some labor migration issues, but right now I want to get to the point of how it matters in our context of environmental kinds of issues. And why do I raise these four different definitions across the top here? It really comes down to, these are ways in which it might vary how the US and Mexico try to handle things together in the Tijuana watershed. It may be that when they might ponder, okay, this wastewater pollution is coming from Mexico into the US, if we try and coordinate things together, how are we actually going to, it says here, sharing the gains. So again, as an economist, what does that really mean to me? It often means if, in fact, pollution is controlled somehow by both countries, what are the damages that they've avoided? It's a combination of doing an assessment of how US and Mexico divided up those reduced costs and avoided damages together. And all I'm going to go through here is that these four different ways in which they can cooperate can present four different ways in which they finance things quite differently, but are still, in the end, gaining to cooperate versus not cooperate at all. And so, but what I'm really going to be getting at in my own analysis is that by investigating these four different alternatives, it helps in actually seeing how actual arrangements between the countries have played out in terms of some financial channels that they've really utilized to solve these problems. And I guess that's the beauty of some of the work that I do, is that I actually base it in reality. I'm not sort of making up something that'll probably never happen or never be carried out, but I'm actually trying to help, inform policymakers to fine-tune their approach and solve the problems. So here, let's again go through these four different definitions. These international lawyers with the Helsinki Rule, as it translates into the environmental case here, is that physical measurements matter for sharing the gains. And so, in a very real way, remember that watershed, 3/4 of it is in Mexico. Remember that big drainage area? Okay, so the Helsinki Rule assigns the shared gains based on measurements like land area. Hydrologic share literally means water flow space. And another physical measurement is simply population. So keep that in mind. That's how that law association was involved in helping crafting some rules of cooperation. The equity rule. What does equity mean? We just simply evenly divide things, irrespective, let's say, of how different countries actually might be. Now here's where these two definitions actually bring up economics. The Shapley value, named after a man who actually won the Nobel Prize based on this definition, Lloyd Shapley, who at one time was at UCLA. What did he actually win the Nobel Prize for? He came up with a definition that said the marginal contribution that a country makes should be what they actually receive in terms of the net gain. And he did this in its sort of financial terms, and it was a theoretical model. So, and you can certainly read up on the Nobel Prize. I'm going to actually show you through some calculations what that actually means. If in this case, it actually means the amount of expenditure that a country might place in terms of financing wastewater treatment, that they'd be, I guess, expected to get something out of how much they actually help to reduce the pollution problem overall. Now, this particular definition is not only from economics, but it's actually from an environmental setting. It involved Scandinavian countries dealing with the former Soviet Union in terms of acid rain problems. And specifically, why it's the Chandler Tolkens, two people from Scandinavia, who came up with a statement about how it would be useful to account for time and space in solving a problem, and when you're requiring cooperation over time and space between countries, it should be the case that the country could do at least as good as if it acted on its own over time and space, in really basic terms. But I'll actually show you how these four definitions play out in measurements in this particular watershed. Well, in order to make this real, or place it in the context of how these definitions would actually result in commitments between the US and Mexico and financial channels, I have to talk through how these countries relate to each other through some institutions that might actually have the wherewithal, the ability to start setting up wastewater pollution treatment plants and or some other pollution control efforts. So let's walk through a really brief history of some of the institutions that really impact how the US and Mexico relate to each other, and then actually allude to, in a very real way, how the US, Canada, and Mexico relate to each other trilaterally. So for a long time, 1944 through 1994, there is still a recognized system of governance through the International Boundary Water Commission, but they kept separate offices, one in the US, one in Mexico, and really their primary function was to talk to each other occasionally over water allocations out of rivers like the Rio Grande for water use. They really didn't have discussions over water quality, or let's say pollution flowing between each country. It was really just water quantity. And there still have been shared battles over whether in drought years, some of the allocations that really should be going to Mexico really are finally getting there or not. So I would say that in many cases, some of these are ongoing discussions that require constant interaction between the countries. It's not that they solve them all in one day and everything's over in terms of discussion. Okay, that was up through the mid-90s. Then, formally, in 1995, trilaterally, Canada, the US, and Mexico signed a trade agreement. This is the acronym for the North American Free Trade Agreement. And part of it was a signed agreement that formulated a couple of institutions on the southern border. One called the Border Environmental Cooperation Commission, or BEC, as I'll refer to it here, and another one called the North American Development Bank. What does it mean? Well, by formally signing the formation of these institutions, there was some recognition that the institutions would, in fact, be the group that helps bring about projects that would solve shared pollution problems. So here's some long phrase to get at that point, that the Board of Environmental Cooperation Commission would actually be certifying projects, and in many cases, they can receive projects that are submitted to them by really any public or private entity. It could be a city, let's say the city of Ciudad Juarez, or any entity that is interested in having the approval by this Board of Environmental Cooperation Commission to help in terms of implementing some form of, it's called environmental infrastructure. That phrase literally means pollution control projects, either in waterways, or in this case, solid waste management, trash collection, road construction to reduce emissions to air. And another purpose that this commission serves is actually providing some help for cities to actually prepare proposals for these projects to be planned out. The North American Development Bank is actually a bank that helps finance these projects. So I wanted to quickly say, in a very structured way, these institutions that were set up in 1995 are binational in nature. There's 5 members from each country in both cases, for Environmental Cooperation Commission and the North American Development Bank. So they actually have one office where the 5 members of each country in both cases are discussing things, and they're actually making decisions together to approve of these projects, or in fact, in a very real way, where they're actually discussing financing of these projects, either through grants or loans. We'll get into a bit more description about the financing as we move on, but I'll just briefly say, in 2000, there was actually this other channel of money coming into the binational institutions, and it was specifically from the U.S. Environmental Protection Agency, some grant monies. So what do grants mean? Well, you're all students, and hopefully you've received some grants, maybe to go to school here. What does that mean? Well, it's free money, right? That's a good thing. That's different from a loan, where you might have a bill at the end of your studies to pay back, right? What would you rather have, a grant or a loan? Okay, you're a good economist. And many of these cities along the border would also like grants rather than loans. In many cases, remember, their financial abilities to pay back things matter. So the intent here was to at least get these projects going. And then, in many cases, we're actually going to explore this as we investigate some of the decision making, that the projects themselves, in some cases, they were financed with grants or a combination of grants and loans, and then the nature of the projects often mean that they set up some user fees later for citizens to pay off these projects over the long term. Typically, I don't know if a lot of people know this, the lifetime of a typical wastewater treatment plant. Well, it might be, 50 years, something like that. So you build something up front, a lot of heavy duty, expensive costs. I'll show you some of the dollar values on some of these projects. And in many cases, to absorb all that money all at once just to get the thing going, you might have to stretch out those, user fee paybacks over, a good chunk of time. So just to remind myself and you of what's going on in this economic model, again, of the game, these countries involved in making these decisions, and in this case, through these institutions. They're trying to minimize costs of pollution control, in this case wastewater pollution control, and the damages that might be experienced, both upstream and down. And what's often involved in my analyses that are quantitative is to do a very good job of modeling the pollution itself from upstream to down, with a lot of information and help from some hydrologists and from some pollution, fate, and transport people. So I have to include that in the form of some of the data I'll talk through to do that. And then, with all this sort of framework, I'm going to compare cases of where US and Mexico actually then act together to minimize these costs and these damages versus if they did it separately, and then explore, again, the financial arrangements under these 4 different definitions of what cooperation means, these different shares going on of the minimizing costs and the avoided damages, and then investigate, what does it really mean in terms of financial transfers that might be going on to get downstream and upstream to work together, things like that. So, this is in fact an empirical study. Here's where I have to gather a lot of the numbers and the details for this. So I have to do a really good job of describing pollution flow. And so I talked to, and by the way, this acronym here is for total suspended solids, a measure of wastewater pollution. And some of the efforts really are focused on some studies that were done in the Tijuana watershed that arrives finally in this wetlands on the US side, and then also it's flowing out of Mexico. So part of what I have to do is, quantify the costs of treating things upstream in Mexico before it crosses the border, and the flow of things. And then if it arrives in the US, the costs of actually, and this terminology basically means that I'm doing some statistical estimation of the costs based on the flow and the accumulation of this wastewater in either place. I just wanted to show you a picture of, it might not be a conventional treatment plant, that's often the investment. What does this phrase mean? It means what we want. And in fact, this is a picture of part of the Tijuana watershed in Mexico, and it's showing some actual variations in a theme, in that, as I was telling you, some of this is sprawled urbanization that's leading to erodibility and some things arriving on our side of the border from, probably poor planning or rapid urbanization. So in many cases, a lot of the water pollution control could actually be doing a better job of actually urban management or shoring up some, as they call them, riparian space of the drainage areas. And so in many cases, and again, this is an economist trying to describe a biologist's effort. In many cases, it involves conservation biology, helping restore some riparian habitat wetlands, and letting the wetlands actually do some filtration itself to retain some of the what could be eroded areas and actually retain it in Mexico rather than it crossing the border and presenting a sedimentation pollution problem. Okay, so basically, this is kind of a repeat of some of what was the institutional history. This is again a description of that membership of both the agencies. And again, this is a tally of specifically this watershed of what's been, well, it's actually a tally of various expenditures going on across the border, but it mentions some of the sources of grant funds between the two agencies. And just to give you an idea that as of 2006, there was, $877 million in grants spent, $1.2 billion in loans for a variety of border projects. And as of now, actually this month, last week, both of these agencies held a meeting in Tijuana. And here's the tally. 82 projects in the US, 95 in Mexico. That's 177 projects. Remember back to one of the original slides, the projection back in the late 90s was 180 projects needed. Getting pretty close. But just to give you some idea of what their sort of prioritization has been, 86% of those 177 projects are water, wastewater dominated, 40% are solid waste and air pollution related. So my analysis of that data collection that I was doing is for this period of time when I was doing this study of this particular watershed. And just to give you an idea of some of the data I worked with, we're not going to march through this table. This is what the BEC has on its ledger. It's basically the names of various projects across the 1,800-mile border, and oftentimes, this fits into some of the sharing rules concepts, there's this estimation of the population to benefit from each of the projects. There's a quantification of if there's been technical assistance in terms of monetary values spent by each of the border agencies for planning each type of project, the project's total costs, and whether it's been financed by grants or by loans, and the type of project it is, either WW wastewater, W for water, solid waste is SW. So had to utilize data like that, marched down to Ciudad Juarez to meet with the Border Environmental Cooperation Commission to get some of that data. And also, a very important part of the calculation is to do some sort of estimation of damages. And with the help of some people from UC Irvine, some epidemiologists, Betty Olson, one of them, was in terms of actually, remember once again that picture of the watershed, the ultimate destination of a lot of the drainage from the Tijuana River watershed is at Imperial Beach, coastal waters. So what we were attempting to do was estimate, okay, supposing, some form of damage is the water quality impacts right at that beach. If in fact it means that it's number of exposures and an illness rate, there's a technique used by some economists to do a cost of illness. And it's considered a lower bound estimate, just to gauge what might be one impact. And in this case, it's some form that people were affected simply by the water quality, perhaps resulting in gastrointestinal illnesses. And again, the epidemiologists, including Betty Olson from UC Irvine, had some data, some information on these illness rates. So the cost of illness often involves some estimates on lost wages and/or medical costs that go into dealing with being ill, from in this case exposure through coastal swimming. Okay, that's a different form of damage, and you might say, gee, what's left out of this estimation altogether, or why it's considered a lower bound, is that we haven't even quantified any damages in the wetlands itself to receiving all this sort of uncontrolled water pollution into the wetlands. This is a free wetlands, meaning even though it's designated as a national wetlands of significance, there's not an entry fee. You can just show up and look at, the migratory birds or tromp around the wetlands. And so any effort to try and quantify that would be certainly over and above what damages we captured here. On the Mexican side, there has been some gauge of property damage from this Mexican Association of Insurance Institutions, where there was some attempt to actually place some value on the lost, those sort of makeshift structures on the hillsides that were eroded, some property loss there. Okay, we're not going to read through this table, but I wanted to show you that and kind of in a general organizational way. This is a way in which to organize the comparison of cooperative type outcomes versus non-cooperative outcomes. And the bottom line is, in these different calculations that involve measuring the 4 different measures of sharing rules, that cooperation results in lower quantities of the stock of pollution, as well as more pollution being abated by both countries under cooperation than non-cooperation. To really get at the comparison, I'm actually going to show you a summary of what this table means in words, but I wanted to actually point out a couple things in this table. These columns, these 3 columns, are actually attempting to work through the Helsinki rule. So remember again, that was the International Law Association's definition of how countries that are cooperating cooperating together would divide up the gains. And they based it on physical measurements of population, land area, and hydrology. And all I wanted to demonstrate here is that if you take into account those physical measurements, let's say the population in the US is actually larger than Tijuana, then that would change the share of what each country would experience under cooperation, versus if it's based on land area, where Mexico's watershed, 3/4 of it in Mexico, or the hydrology drainage would mean the share to Mexico is actually quite significantly greater. Shares change when you bring in the other definitions, the Shapley value and the Chandler-Tolkien's value, and the equity value simply would mean a 50% split between the two. But what I've worked out here is the actual cost shares between both countries, and then what the financial transfers might be from downstream to upstream. But let me just summarize these findings from that big table of different things. And by the way, besides just kind of looking at the variations in cooperation versus non-cooperation, I also wanted to do a sensitivity analysis where things might change over time, like costs or damages, where it might motivate the countries to act differently too. So just wanted to mention that was in there. But let's sort of see what really resulted in this analysis. Well, it's better to cooperate, match the scale of management to the scale of the pollution problem. So cooperation literally means this is a binational strategy then, where both countries are doing something, coordinating efforts. And it's optimal in terms of they minimize the pollution costs together and the damages, and the stock of the ultimate wastewater pollution is actually lower. In all cases, under the 4 different forms of cooperation, those different rules, there are some transfer payments that are generated to induce upstream Mexico to control wastewater. And it's actually cheaper by transfer payments. What I mean is that it's actually cheaper for the US to spend money solving the problem upstream in Mexico than waiting for it to arrive downstream and experience the damages. And so the cooperative share is highest in Mexico with the physical measures of land area and hydrology. So they'd actually get 90% of the share of cooperation if those were the terms under the Helsinki rule of dividing up the gains for cooperation. In looking at the other sharing rules, the Shapley value, the Chandler-Tolkien's rule, they still allocate positive transfers to Mexico, and they're based on this sort of economic incentive sort of logic. Okay, at that time, from 1994 through 2006, the data I was looking at for that projection of things, the level of funding more closely followed the population share physical measurement Helsinki rule of the way in which financing through the Border Environmental Cooperation Commission and the North American Development Bank were starting to finance things there, the wastewater treatment plants. Now, what I want to tell you is that as of a week ago, Tuesday, so February 9th, both the Border Environmental Cooperation Commission and the North American Development Bank met in Tijuana, and they approved of 2 more wastewater treatment plants in Baja California, right in Tijuana. And so, some sort of confirmation of my efforts here, and by the way, this publication came out probably 3 or 4 years ago, on this analysis, that it's basically, because in sort of investigating these 4 different sharing rules, it turns out that now, as opposed to previously, if the data stopped at 2006, it would have been that the cooperation was following more of this physical measurement of population share. But now, in a very updated way, through last week, it's more the case that it's kind of straddling in terms of the amount of money, and again, this prevalence of solving the problem upstream in Mexico, that the amount that's being shared or spent in the financial transfers is straddled between using the area hydrology measurements of Helsinki rule, which, again, this is kind of what's said here, the cooperative share is highest for Mexico. And it's then also approaching the Shapley value, where you have this marginal contribution of gain to the overall total cooperative setting. So that's actually considered a good thing. They've actually fine-tuned their approach to solve this pollution problem over the long term. So that's a look at one watershed. I want to actually move us to, how am I doing on time? Because I'm not sort of accurately.
20 minutes, 15 minutes?
How many?
15.
Okay, all right. This will be quicker. I want to talk through the case where now it's actually an effort that I did to take a lot of decisions made by the Border Environmental Cooperation Commission over the entire 1,800-mile border and look what they were doing in terms of the projects they were approving. So I'll just quickly run through this. It's a statistical analysis where I was looking at whether the Border Environmental Cooperation Commission approved or rejected projects, and what were the different factors motivating their approving or rejecting. Remember, 5 members are from the US, 5 are from Mexico, and they make decisions together on spending, approving of these projects for environmental improvement. So bottom line, I'm going to show you, just walk you through the results, and then convince you that I did this statistically with the next slide. But what are the results? Basically, this agency, the binational agency, favors projects that really do solve transboundary pollution problems. So the proposals really have to, in fact, convince this agency that they're having an impact on both countries' pollution problems, and that they actually have measurements up front of how they're going to improve environmental and public health. I actually have some variables for this in the analysis. The agency itself continues to favor water quality projects the most, rather than, let's say, solid waste or air quality. And in terms of some measure of what might be some various measures of sustainability over time or something, job opportunities seem to be a big thing. That projects will be approved if they can actually show evidence that they're creating jobs in the process. They're actually more favored than projects that actually generate revenues on their own from reclaiming resources, let's say solid waste recycling kinds of efforts. And it doesn't seem to be a goal of this agency to do an equitable split of financing. Remember the numbers count, the tally on how many projects are approved in Mexico versus the US. There's 95 in Mexico right now, and about 20 less in the US. So remembering back to this asymmetry going on, the upstream, the downstream, that should matter in terms of if you solve the pollution problem upstream, it may be the case that you actually have a project occurring upstream more often than just equitably split. And it's the case, in a very real way, for financing that even though this agency does approve of projects taking place in the upstream country along this long border, it may be the case that even though the project is situated in Mexico, it's not Mexico paying for this project. It's often with this mixture of loans, grants, that it's actually monies that are coming from elsewhere, both countries, that are actually financing this. And remembering again, these cities often produce things that then go much further than their own consumption. So in many cases, these federal monies, that finance these agencies that ultimately, dictate where these projects are situated, it may be the case that that's okay, that the money federally from the rest of the country is financing, places that actually are experiencing this pollution for things that we may consume in the rest of the country. Keep that in mind from just a kind of an accounting perspective. Here's just a general slide to show you that I actually did conduct a statistical analysis to produce some of these results. I'm going to quickly allude to another transboundary pollution problem because it's a very real one, important one that connects all 3 countries, and that's air pollution. And in a nutshell, I'm just going to tell you the largest source of air emissions on both international borders are in traffic delays, entering and exiting these countries. I don't know if you've ever sat in a car at one of those borders, border checkpoint, But in many cases, you're often perhaps behind, you know, a lot of other cars or whatever, and they're all piled up, and a lot of engines are running. And again, economist, not an air chemist, but I'll just briefly say that there is a correlation. If you've got an idling engine, often a diesel truck, idling, or they stop and start the diesel engine, they're actually creating these horrible emissions we'll get into some of the names of the pollutants very quickly here, but in a very real way, my analysis here is focused on kind of a different frame of reference, whereas in the past, I was looking at cooperation through, you know, institutions that are making decisions on setting up treatment plants, let's say, right at the shared border. In this case, I'm actually going to examine some incentives where it's actually transportation participants, you know, car owners and commercial truckers or something, to examine where some trinational policies, when thought out properly, have worked or not to try and reduce air pollution at these two borders. So just making the initial connections of, you know, traffic delays at borders cause air emissions. These air emissions are kind of problematic for people who are actually breathing the air there. And so a really basic question that I'm going to hopefully answer is what policies have impacted transportation and air pollution at the border? You know, have they worked or not? So very quickly, I'm going to talk through, you know, what it meant to do this analysis. Had to collect a lot of data. It's a very data-intensive project to get at really good forms of, you know, time series data. I don't know if anybody in the room has run some statistics. I had to get at, you know, a length of years and different borders. So it's air quality measurements along those borders, transportation flow data, cars, trucks, and you know, some way of controlling for emissions elsewhere, away from the border, like in the neighboring cities right near the border, and then get at the aspects of when different policies went into effect or not along the different border ports of entry. So, really basic setup of the data intensity of this project. Here's the years that are involved, and they kind of cover some key ways in which these policies are actually quite different in their intent and what they're attempting to do. So basically, panel set, what does that mean? Basically collecting a lot of data over time and space. And on the US-Canada border, I had data enough for 6 different ports of entry and 8 different ports of entry on the US-Mexico border. And so I had to get data for transportation flows of trucks, cars, this is containers carrying different things, and buses. Air quality data from some air monitoring stations of, I don't know if you've seen these acronyms for different pollutants, but this is ozone, nitrous oxide, sulfur dioxide, and particulate matter. Sounds very beautiful. I don't know who's that is. Had some trade flow data too. And then what was actually one of the hardest types of data to get was from Customs and Border Patrol on border wait times. Actually, the times in which engines wait at the border to pass through. This is going to be a measure of congestion, and again, the correlation of if in fact these policies may work differently at lowering that wait time, speeding people through the border, and there's less air emissions taking place. Kind of doing some hand waving to explain some of the connections. Here are some of the policies I'm going to try and test out if they had any impact at helping reduce air emissions. One of them has a really long name, Customs and Trade Partnership Against Terrorism, and an acronym that's used is FAST, Free and Secure Trade. What does that mean? Well, it's like a fast pass on the toll roads here. What does that mean? It's basically trucks are screened before they arrive at the border. They're screened to say, okay, they're safe to transport cargo. So trucks in this study are commercial commercial vehicles that are actually bringing things between countries. And they can be issued this, electronic device in their truck so they don't have to stop. And that might mean, in a very real way, they're not idling their engines or doing cold starts that lead to a lot of air emissions. So I'm going to test out. This policy was actually implemented starting in 2003, but phased in. So it wasn't in all the ports at all the time. They phased it in from 2003 and 2006. And as a person who does statistics, it's kind of relevant that things take place differently in a very different way. You're actually able to test out differences statistically over time and space if it had an impact or not. Another policy to test out in a small sample set is fuel policy. A low sulfur fuel was available only on the US-Canada border in 2 ports. So it's actually going to be kind of less of a really dramatic effect here, but I'll say perhaps in the future that might be more widespread. Diesel technology. In a very real way, in 2004, diesel engines were changed in trucks, and I'm going to see if that had quite an effect. I actually add some other policies just to see if the scale of activity going on transportation-wise might have changed, and in this case, road infrastructure might have made a difference. Let me quickly summarize this again, a statistical page. I'm going to show you, just to wrap up here, this is kind of a tally of the pollutants that were actually reduced by different policies and the amount of ports that you saw a noticeable effect at each border. So again, this is the acronym for I call it the trade policy, where trucks, again, commercial trucks were given a pass to be screened ahead of time and not have to wait at the border. So it speeded the flow of traded products, let's say, and reduced air emissions. And again, acronyms for air pollutants, carbon monoxide, ozone, particulate matter, and nitrogen oxides in 6 ports at the US-Canada border and in 8 ports in the US-Mexico border. Another significant policy was changing diesel engines, 2004, for NOx and particulate matter in 6 ports on the US-Canada border because all the trucks in some sense are of the same vintage between the US and Canada. And you could say, we could go into longer discussions here, where trucks vary quite dramatically on the US-Mexico border, but it did have some impact on particulate matter in 2 ports. I'm just going to draw some conclusions because I know I'm sort of reaching that end point. But in a very real way, this study, attempting to just use any available data where I could across both borders, really shows some dramatic things. Very significantly, it is key to control for the cities that are right next to the ports of entry. Again, in a very real way, remember that first map of the entire continent, you have to control for wind patterns that might actually be delivering, some of the pollutants out of the neighboring city to the border itself, the border port of entry. So you have to, in a statistical way, recognize that to be able to distill, whether it's the cities influencing things versus policies that people between the 3 countries are actually trying to implement. So really had to account for that and match it with the air currents that are going on. So in some ways, the north to south air currents were actually, validated here as having an influence. But once those are controlled for, you can still see that the clean diesel policy makes a difference. If you're trying to, have some impact on trucks by getting them to change their engine, it really does help reduce some pretty, in a pretty big way, some pollutants that can be pretty noxious at various ports. And road infrastructure projects did reduce a small amount of ports for a couple key pollutants, carbon monoxide and particulate matter. The FAST policy really was significant across all pollutants that were in our database to measure, and it's across all the ports in the sample, so that was pretty significant. And in a very real way, this policy works in conjunction with reducing the wait times that trucks might actually be generating a lot of air pollution. Wanted to bring this up too because private vehicles, cars pass through borders. Some ports of entry actually only have cars. The commercial trucks are actually stuck off to another port of entry. And so that was important to examine too, what motivates private cars or reductions. And so oftentimes labor forces are given these passes too if they actually are constant travelers across the border. Maybe they're part of the labor force that crosses. And so there was a noticeable change at different ports on the US-Mexico border for some pollutants, and then these two ports of entry are on the US-Canada border. Okay, and there is this recognition that some of these policies haven't been phased in at the same time, so Mexico really does have to go further in actually getting a lot of their trucks to modify their engines too. So it was supposed to be phased in by next year. What are the overall conclusions of these efforts? And I've sort of quickly been showing you sort of a variety of scales, hopefully keeping you somewhat interested in some topics that I haven't delved into. But what's the overall message here? Either through the wastewater efforts where you have institutions making decisions, it's really cooperation, where the management is matching the actual pollution problem that really has made a difference. The money has been spent to solve these pollution problems that they jointly share. And maybe things got bad enough that it really did make them care. My estimates, my attempt to estimate the damages as well as the costs that they face, at least were kind of a good representation of what these agencies that have jointly been formulated do in terms of their coordination efforts. Also, in shifting gears to the air pollution setting, it can also be, if it's not institutions that are actually financing wastewater treatment plants right on the border, then it's actually on a tri-national level jointly agreeing to policies that affect, in this case, mobile forms of pollution between each other. The transportation that's actually connecting them through the ports of entry on the border. These tri-national policies that they've coordinated really can make a difference, in this case, to affect transportation flows and the way in which they can reduce air pollution. Also, I guess I would like to be able to conclude that this effort, these analyses that really have been, quite a team effort, let's say, where I actually do have to go out and collect information and model it properly with the help of some people who actually know good definitions of pollution, or interacting with some of the agencies who actually have some relevant management efforts to model properly here, can actually help inform and make policymakers ponder ways in which they could solve these problems over the long term for these big areas that are actually trying to manage. So with that, I'll end.
Thank you.